So, solving any trigonometric equation always involves reducing it to the most basic form. So, first, let's look at one of the most basic equations you could solve. Uh, for instance, the sine of theta is equal to 1/2. So, in order to solve this, we're solving for theta. So, a common mistake that early students will make is they think that they have to somehow divide both sides by sine to get at theta. But this is, one piece of the puzzle, sine theta. So, what you really have to think of is maybe a unit circle. So, let me sketch a unit circle here. Okay, there's our X and our Y. Not perfect, but I know that 30 degrees or pi 6 has, accidentally erase this, 30 degrees has a sine of 1/2. The other possibility, of course, is radians, pi 6. But sine is positive in both quadrant 1 and quadrant 2. So while pi 6 or 30 degrees is definitely one of the solutions, the other one is over here. So let's draw a reference angle. Looks like this. So if this were 30 degrees, the new angle formed would be 150 degrees. And that, of course, is the same as 5 pi over 6. So we have our two solutions at least on this interval, from 0 to 2 pi, or 0 to 360 degrees. So we'll write those down as radians. So theta is equal to pi sixth and 5 pi sixth. So that's on this interval right here that I'm pointing at. But think about this. I could go around another 360 degrees. And every 360 degrees around I went, I would be at a coterminal angle to my original 30 degrees. So for that reason, if you're listing all of the possible solutions, you would say that theta is pi sixths plus 2 pi times any other factor. Actually, plus or minus 2k pi is what you'll see written. So that includes all of the solutions, at least that are related to pi 6. If you look at 5 pi over 6, the same thing can happen. I could start at this 5 pi over 6, and every 360 degrees around, I would be at a coterminal angle. So theta is equal to 5 pi over 6 plus or minus 2k pi. Or that just means 2 pi times any number of revolutions, positively or negatively. Okay. Here's another very similar looking example, but it just takes it one step further. It says, hey, I have 2 times the sine of pi equals 1/2. So when I solve this, I would solve it by dividing both sides by 2. So my next equivalent equation becomes the sine of theta equals 1/2. And that looks pretty similar to what I just did back here. So it's just one step further in the equation. So we already know we're going to be pi sixth plus or minus 2k pi and 5 pi over 6 plus or minus 2k pi. Finally, let's add one more step to this. 2 pi, or I'm sorry, 2 sine of theta minus 1 equals 0. So we're trying to solve for theta, so let's get rid of minus 1. Okay, so the first thing we do is add 1 on both sides. And now we're looking at something very similar to the previous one. So now we just divide both sides by 2 and get the sine of theta equals 1/2. So now we already know 30 degrees, which is pi sixths, plus or minus 2k pi, and 5 pi over 6, plus or minus 2k pi. Incidentally, if I wanted to solve this in degrees, I could. And a lot of times I encourage students, until they get familiar speaking radian, to speak degree and then translate back to radian. So a lot of students will be able to get that theta is, let me switch colors here, that theta is 30 degrees, but that's also plus or minus. This is only on this interval from 0 to 360 degrees. So we could add or subtract 360 degrees to 30 degrees and keep ending up at a coterminal angle to the 30 degrees. Same thing goes for the 150 degrees. If I kept going another 360 degrees, clockwise or counterclockwise, I would continue to land at 150 degrees. So if you're asked for pi 6 and 5 pi over 6 or radians, sometimes it's helpful to work with what you're more familiar with, solve it for degrees, and then switch it back into radians. So here's one final example. It's not as basic, but it's not super hard, and it involves factoring. So sometimes we have to factor things. So when I see these things, I try to teach students to imagine that x is equal to the sine of theta. So that would be like having sine 2x squared minus 7x plus 3 equals 0. So we know that if we can, we'd like to factor this guy. And if it factors, it looks like this. And I'm looking for factors of 3 such that when I put them here and here, the outer and the inner products add up to -7. So that's not too bad to do. -1 and -3. So the reason they're both minus is, double check it, -1x and -6x. So -1 and -6 adds up to -7. And let's see, last times last, -1 times -3, +3. So pretty sure that we got this one. So just pretend that the sine is an x. So that would end up being 2 times the sine of theta. And I'll do exactly like I did over here to the right. I'm going to write it out the way I know it would look if it did indeed factor. Now, most of your problems in your textbooks are going to factor. They don't always, they're contrived problems. They're designed to work. So, but I will show you an example here with this other factor. What's going to end up happening here is going to be kind of interesting. Well, maybe not interesting, but so I have two factors. So if this times that equals 0, remember the zero product property says that either this factor or that factor has to equal 0. So I'm going to write that down. 2 sine theta minus 1 equals 0, or sine of theta minus 3 equals 0. All right, so one of the first ones I'll deal with is this one, just because I'm seeing that I'm going to get the sine of theta equals 3. And that makes no sense because sine ratios are all between -1 and +1 inclusively. So this is no solution over here. Okay, no solution. There is no ratio of 3 for the sine. So, but back over here, we have something that looks oh so familiar now. 2 sine theta equals 1. Hey, we've done this a couple times. And that's what happens when the more you do these equations, the more often you're going to see the same sort of stuff crop up again and again. So we're going to go with theta is pi sixth 5 pi over 6, at least from 0 to 2 pi. Now, if you liked how I did degrees before, you'd be looking at this. We'd be saying that theta is equal to 30 degrees, or theta is equal to 150 degrees. Okay, so that is our conclusion for our basic trig equations. Next video, we'll have some more complicated looking ones. Till then, we'll see you next time.